Hello everyone, very warm welcome to ITLS Academy. Our lecture is Principles and Practice of Sterilization, and this is continuation of Principles and Practice of Sterilization. This is part 4. We have already discussed part 3 of Principles and Practice of Sterilizations, and we have seen a lot of methods of sterilization. Few remaining methods of sterilization we will cover in this particular lecture. So let's continue. We have seen ethylene oxide in our last lecture. Here we are going to see formaldehyde. So the very first point is formaldehyde gas for use in sterilization is produced by heating formalin, and this is 37% weight by volume. This is weight by volume. Weight divided by volume. And this 37% weight by volume aqueous solution of formaldehyde, and it is heated to a temperature of 70 to 75 degrees centigrade with steam, leading to the process known as LTSF. Next point, formaldehyde has a similar toxicity to ethylene oxide. Toxicity level of formaldehyde is similar as ethylene oxide that we have discussed in our previous lecture. And although absorption to materials appears to be lower similar, desorption routines are recommended. A major disadvantage of formaldehyde is low penetrating power, and this limits the packaging materials that can be employed to principally paper and cotton fabric. Here comes sterilizer design and operations. First point, an LTSF sterilizer is designed to operate with subatmospheric pressure steam. Air is removed by evacuation and steam admitted to the chamber to allow heating of the load and to assist in air removal. The chamber temperature is maintained by thermostatically controlled water jacket, and steam and condensate are removed via a drain channel and are evacuated condensers. Next point is At the end of the treatment period, formaldehyde vapor is expelled by steam flushing and the load dried by alternating stages of evacuation and admission of sterile and filtered air. The sterilization period starts with the release of formaldehyde. Another type of sterilization process is radiation sterilization. First point is several types of radiation find a sterilizing application in the manufacture of pharmaceutical and medical products. Principal among which are accelerated electrons, particulate radiation, gamma rays, and ultraviolet light. And these both are electromagnetic radiations. The extent of DNA damage required to produce cell death can vary, and this together with the ability to carry out effective repair probably decides the resistance of the organism to radiation. Next point is radiation sterilization with high energy gamma rays or accelerated electrons has proved to be a useful method for the industrial sterilization of heat sensitive products. However, undesirable changes can occur in irradiated preparations, especially those in aqueous solution where radiolysis of water contributes to the damaging process. Next point, thus radiation sterilization is generally applied to articles in the dried state. These include surgical instruments, sutures, prostheses, unit dose ointments, plastic syringes, and dry pharmaceutical products. Ultraviolet light, with its much lower energy, causes less damage to microbial DNA. Sterilizer design and operations for radiation sterilization. So first one is gamma ray sterilizers. First point is gamma rays for sterilization are usually derived from a cobalt 60. That is, in short, 60 CO. And this is 60 CO source. Here, cesium-137 may also be used as a source for gamma ray sterilization. And here cesium with a half-life of 5.25 years, which on disintegration emits radiation at low energy levels of 1.33 and 1.17 millivolt. For safety reasons, this source is housed within a reinforced concrete building. It is housed in a reinforced it is reinforced concrete buildings with walls some 2 meter thick. The walls of these reinforced concrete buildings are 2 meter thick, and it is only raised from a sunken water-filled tank when required for use. Next point. Articles being sterilized are passed through the irradiation chamber on a conveyor belt or monorail system and move around the raised source. The rate of pass is regulating the dose absorbed. Here radiation monitors are continually employed to detect any radiation leakage during operation or source storage and to confirm a return to satisfactory background levels within the sterilization chamber following operation. You can see this is a diagram for the radiation sterilization. This diagram is of a typical cobalt-60 irradiation plant. This is source hoist. You can see here it is source hoist. It has concrete shielded chamber. You can see walls, and thickness of walls as we have studied is 2 meter. These are product boxes that are moving on the conveyor belt continuously. This is discharge conveyor. This product is discharged over here. Supply conveyor is here. You can see this is supply and this is exit or discharge. It contains control console. This is cobalt-60 transport container. This transports cobalt-60. This is cobalt-60 source submerged in storage pool. These are storage pool, and CO60 is submerged over here. And this is source pass mechanism. Gamma rays radiation we have already seen. Now we are going to switch to electron accelerator. And the very first point is two types of electron accelerator machines exist. The electrostatic accelerator and the microwave linear accelerator. And these are producing electrons with maximum energies of 5 millivolt and 10 millivolt respectively. Although higher energies would achieve better penetration into the product, there is a risk of induced radiation. Next point, articles for treatment are generally limited to small packs and are arranged on a horizontal conveyor belt, and it is usually for irradiation from one side but sometimes from both. Varying extents of shielding depending upon the size of accelerator are necessary to protect operators from X-ray generated by the Bremsstrahlung effect. Next comes ultraviolet irradiation. The point is, the optimum wavelength for UV sterilization is around 260 nanometer. A suitable source for ultraviolet light in this region is a mercury lamp giving peak emission levels at 254 nanometers. Next point, operators present in an irradiated room should wear appropriate protective clothing and eye shields. Another type of sterilization we are going to study is filtration sterilization. So the very first point in filtration sterilization is the process of filtration is unique amongst sterilization techniques in that it removes rather than destroys microorganisms. The process of filtration does not kill microorganisms, it removes them by filter. The principal application of sterilizing grade filters are the treatment of heat sensitive injections and ophthalmic solutions, biological products and air and other gases for supply to aseptic areas. Next point, they may also be required in industrial applications where they become part of venting systems. And this venting system is present on fermenters, centrifuges, autoclaves, and freeze dryers. These filters are then placed on the surface of a solid nutrient medium and incubated to encourage colony development. Next point, the major mechanisms of filtration are sieving, adsorption, and trapping within the matrix of the filtered material. Of these, only sieving can be regarded as absolute since it ensures the exclusion of all particles above a defined size. The potential hazard of microbial multiplication within a depth filter and subsequent contamination of the filtrate, that is microbial growth through, should be recognized. Filtration, sterilization of liquids. First point, in order to compare favorably with other methods of sterilization, the microorganism removal efficiency of filters employed in the processing of liquids must be high. It may be tempting to assume that the pore size is the major determinant of filtration efficiency, and two filters of 0.2 mi pore diameter from different manufacturers will behave similarly. Next point, the major criteria by which filters should be compared, therefore, is their titer reduction valves, that is, the ratio of the number of organisms challenging a filter under defined conditions to the number penetrating it. Membrane filters in the form of disc can be assembled into pressure operated filter holders for syringe mounting and in-line use or vacuum filtration tower devices. Next point, membrane filters are often used in combination with a porous grade fiberglass depth pre-filter to improve their dirt handling capacity. Filtration, sterilization of liquids we have completed. Now next one is filtration, sterilization of gases. So for the gases, very first point is the principal application for filtration, sterilization of gases is in the provision of sterile air to aseptic manufacturing suites, hospital isolation units, and some operating theaters. Filters employed generally consist of pleated sheet of glass microfibers. Next point. In our previous point, filters consist microfibers, and these filters are made up of microfibers. So we are going to our next point, and this is that these high efficiency particulate air HEPA filters, as these contains microfibers, these are known as HEPA filter, that is high efficiency particulate air filters. And these filters can remove up to 99.997% of particles greater than of 0.3 FIM in diameter, and thus are acting as depth filters. In these HEPA filters, air is forced through HEPA filters by blower fans, and pre-filters are also used to remove larger particles to extend the lifetime of the HEPA filter. Next point. Other applications of filters include sterilization of venting or displacement air in tissue and microbiological culture. So all the required techniques of the sterilization we have completed till now in 4 parts of this particular topic. So now we will see conclusion of all these sterilization techniques. So the conclusion is a sterilization process should always be considered a compromise between achieving good antimicrobial activity and maintaining product stability. It must therefore be validated against a suitable test organism and its efficacy continually monitored during use. So thank you guys. This topic completes here. Follow ITLS Academy on Instagram, Facebook, Twitter, YouTube, WhatsApp and LinkedIn. For latest videos and updates, subscribe ITLS Academy on YouTube, and you can also get it on Google Play Store. Thank you for watching. If you like this video, then like, share and subscribe ITLS Academy. For any help or query, you can call us on 7080833450, and you can also reach us on www.itlsacademy.com. Thank you very much again.